solving right triangles. Now, the best thing about this, solving right triangles, is that you already know how to do it. Okay, we've already gone over tangent, sine, and cosine. The difference between 9.4 and 9.5 is that you were using the ratios to find sides. Well, now you have sides, and I'm going to show you how to find the angles. So this is the inverse operation. This is the opposite of using the sines, cosines, and tangents to find the sides. Now we have the sides, and we're going to find the angles. It's exactly the opposite. So make sure your name's on your paper. And here's my objective for you. In 25 minutes or so, you should be able to, students will be able to find missing angle measures. In right triangles. Okay, let's focus that. So when I look at this triangle here, it says what type of triangle is ABC, and how do you know? Well, first of all, I know it's a right triangle, and then I know I've seen these 1, 2, and root 3 things before. So I'm going to look at my little card. Look, it's right here. It's a 30, 60, 90. In fact, it looks like this, where x is 1, 2x is 2, and x root 3 is root 3. So it is a 30, 60, 90. And I know because of the side lengths. Okay. Now what I want to do here is determine which of these two, A or B, has a cosine of 0.5. I want a cosine of, and I'm going to say theta, a cosine of 1/2, which is 0.5. So I want the adjacent side over the hypotenuse. In fact, let's just rewrite our little things here to remind us, SOHCAHTOA. So this is the way I remember. The sine of this angle is the opposite over the hypotenuse. The cosine, I'm just doing A, is the adjacent over the hypotenuse, and the tangent of an angle is the opposite over the adjacent. So remember, SOHCAHTOA. So these here, if I want this to be the adjacent over the hypotenuse, that's angle B. So the cosine of B is equal to 1/2. Any questions? Right? Now, here's the thing. What has to be this angle? Now, I'm going to grab my card again. I know that the shortest side is always across from the smallest angle. So this is 30. And if that's 30 and that's 90, this has to be 60. And the question says, what must be the measure of the angle from problem number 1B? It has to be 60. By the Triangle Sum Theorem, which means they have to add up to 180. Or what I want, and I want you to add this, sorry, measure of angle B equals 60. And I want you to add this in parentheses. You'll understand why in just a second. So the measure of angle B is equal to, you're going to write cosine, and then you're going to put a little -1 power up here. Okay, it's like an exponent. It's not, but it's like an exponent. And then in parentheses, you're going to put 1/2, and you're going to put equals 60 degrees. And I'll explain this to you right here next. Now, what this says is that the measure of angle B is equal to the inverse cosine of 1/2. So here's my little explanation of what inverse means. When you're a kid, you learn to add, and then right after that, you learn to subtract, because adding and subtracting undo each other. Then you learn your multiplication tables, and then you learn to divide, and then they undo each other. Then you learn to square a number, and you learn a square root, because they undo each other. So here, what we know is that in 9.4 and 9.5, we figured out how to use these ratios, these trig ratios, to find side lengths. Now, you're going to use side lengths to find angles. So this inverse trig ratios are if you have sides and you want to find the angle. If you want to just do the regular trig like this, you have the angle and you want to find the side. They're exactly opposite. But you know all kinds of things by now. You know the Triangle Sum Theorem, so you can figure out other angles. If you have two sides, you've got the Pythagorean theorem to figure out a third side. This so happens to be if you have just sides, no angles, and you want to find that. So this says that the cosine, the inverse cosine of 1/2 of that ratio is equal to 60 degrees. So when you use inverses, you're going to get degrees as your answers. Here's how it works. So, just as a reminder, so, ka, to, what? You can't write it enough. Every time you write it, your brain is adding a little bit more down on that synapse, and it's reinforcing it. So, A is going to be our acute angle. I'm going to call it theta. And here's the right triangle ABC. So, if I want to do inverse tangent, what that means is that I've got tangent of theta. Okay, tangent of theta is equal to opposite over adjacent. If I actually have these sides, but I want to find that angle, then the opposite, or the inverse, is tangent. And I write this little -1, and that means inverse. It doesn't mean traditionally powered, it means the inverse of, and the tangent inverse of this ratio is equal to the angle, and this ratio is BC over AC. So the inverse of the ratio is equal to the angle. The tangent of the angle equals the ratio. The inverse of the ratio equals the angle. Those are inverses. That's what an inverse is. So we'll write out the ones for sine also, and for cosine also. So if alpha is here, then, if theta is here, then the opposite is BC, and the hypotenuse is AB. And then if I write the inverse, it's going to be sine inverse of the ratio equals the angle. And last, if I do the cosine of A, the adjacent side is AC, the hypotenuse is AB. And then if I want to find the angle, the inverse of this ratio is equal to theta. This is what we're doing today. This is how we solve a right triangle. Now, one more thing I need to add while you're writing that down is, if the directions say solve a right triangle, nowhere on here does it actually say this. Solve means figure out all three angles and all three sides. Solve a right triangle means all three angles, all three sides. And you have every tool you need now to do that. I'm going to show you how to do it for these angles. Any questions? Feel free to unmute yourself, raise your hand, butt in, whatever you need to do. So I don't want to go too fast on this. This is super important, and I hope it'll be easy for you. Now, examples. Keep this in front of you. Determine which of the acute angles have a sine of 12 over 13, sine ratio of 12 over 13. Then approximate that angle to the nearest hundredth, that angle measure. So what I'm looking at here, right, is 12 over 13. And I want this to be the opposite over the hypotenuse, right? Well, I think you can tell that 12 is opposite angle E. So that's going to be your first part. Now, what we're going to do is we're going to find angle E. So you're going to write that the measure of angle E is equal to the inverse of sine, the opposite of this, of that ratio, and you're going to figure out what it is using your calculator. Well, I'm going to do this. I'll do squiggly because it's approximate, it's not exactly. Okay, so this is where you grab your calculator. All right, hopefully everybody sees where that comes from. Now, if I push on this one, if you have a TI, really any model of TI, what you're going to do is pick this function. Now on my TI, the sine function is right here in green above that button. Hope you can see it. I'm trying to get it clear. So it says sine, cosine, tan, but right above it in green, it's got sine to the -1, cosine to the -1, tan to the -1. So because it's green, I have to press this second button first. Okay, so if I press second and then the sine, it's going to give me that function. So hopefully you can see now that it says sine to the -1. And I just put in 12 divided by 13. That's called my argument. So I'm going to do 12 divided by 13, right? Because that's what that says. I'm going to end my parentheses, and I just press equal or enter. And it gives me 67.38. That's my angle. That is the angle. 67.3. It said 100. Okay, so that's 38 degrees. Now, if you happen to have a different calculator, remember how the TIs are different from the Casios or Sharps or even your phone, you're still going to, where that came from, you're still going to have to find where your sine thing is. Okay, so first of all, make sure it's in degree mode. It should say a D or a DEG. If it doesn't, I'll have to help you get it in a different mode. And here's my sine, cosine, tangent buttons. And right above it, you'll see in yellow, sine, cosine, tangent, inverse. So for this one, I have to press the shift first. So if I press shift and then I press sine inverse, nothing happens. Remember, you have to do the argument first, which means on this one, you have to do 12 divided by 13 first, and then get your answer, so press equal. So that's 12 divided by 13. That's the inverse sine I want. So now that it's on my screen, I can go shift, sine inverse, and I get 67.38. So again, this you're going to do the argument first, and then you do the inverse. But both of them gave me exactly the same answer. Try it on your calculator. See if you can also get that. And further, if you want to just use your calculator on your phone, if you use an iPhone, you should be able to do it exactly the same way. Remember, you tip it and turn it sideways, and it will give you this. Only here, there's no shift button where you can see them. So in order to get, here's your sine, cosine, tangent. In order to get the inverse, you have to press the second button. It's right there. And now you should be able to see it says sine to the -1, cosine to the -1. And again, you'll be able to do exactly the same thing. Okay, so I do second, and I do sine inverse, well, nothing's going to happen. So you have to actually, on these, remember, 12 divided by 13 first, and then you do second sine equals. Okay, hold on. Clear. Okay, 12. This is an iPod, so I'm just making sure it works. It should work the same. So then second, there we go. It has to switch. Sine, and it gives me 67.38. So that should work exactly the same. If you can't get it with one of these methods, TI, Casio Sharp, or iPhone, then let me know and we'll screen share and we'll figure it out together. Any questions about this? Because I'm going to just go fast from now on. Okay, so number 5 says, I have angle G, angle H, and angle K. Now we're going to use our calculator, so now you're going to practice to get to the nearest hundredth. So I have tangent of G equals 0.43. So the way you're going to do this is that you want the inverse tangent of 0.43, and that's going to equal your ratio. Okay, so again, on this one, I want tangent inverse, so I go second tan, and then I'm going to do 0.43, press equals, and I get 23.267. Actually, it says hundreds, so I will round that to 27. And it's sort of squiggly because I'm rounding. 23.27 degrees. Same thing for this one. I have the ratio, I want the angle. So I'm going to do the inverse of 0.68 sine. I'll do it on this one to make sure we've got it all. Okay, so I do the 0.68 first, and then I do inverse or shift. This is sine, so I want that one. And it gives me 42.84, and 84 is closer to 840 than 844. So 42.84 degrees. That's our angle. We're getting the angle. And last, this is going to be, I want cosine angle equals 0.94. So the inverse of 0.94 equals, okay, we'll do squiggly, inverse cosine 0.94, 19.95, let's round that up to 19.95 degrees. Okay, so again, this is where you ask a question, if you have any, because I got to turn the page over, and we're going to go in a slightly different direction now with 3 more examples. All right. So this is what I said earlier. To solve a right triangle, what it actually means is to find all unknown sides, lengths, and measures. I gave myself a note here. Whoops. I want to box this. I want to make this important so I remember what it means, okay? You can solve a right triangle when you know either of the following. Really what you need, you either need 2 sides, right, because that can get you ratios, or you can use the Pythagorean theorem to get the 3rd side, or you need 1 side and 1 angle. And then you can find another side with those ratios. So that's all you need to find all 6 things. This one says, solve the right triangle. Give answers in exact form and round. So I have legs of 2 and 3. I'm going to use the Pythagorean theorem to find c. So c squared equals 2 squared plus 3 squared. Use the space well. C squared equals 4 plus 9. So c equals the root of 13. And that is the exact form. if I want to know what root 13 is, I go, where's my square root button? There it is. It's approximately 3.61 because it said hundredth. Okay, so I now know the three sides. Now I can figure out the angles. I just have to either use A or B, and you pick. So if you use B, you could do 2 over 3 for tangent. You could do 2 over root 13 for sine. You could do 3 over root 13 for cosine, and you could do the same thing for A. But once you figure out A or B, then all you have to do is subtract to get the other one. So I'll just go ahead and do B. Since I have 2 and 3, I want the tangent inverse of 2 over 3. And that's going to give me the angle measurement of B. So inverse tangent, 2 divided by 3. Ta-da! 33.69 goes here. Degrees. That is exactly what the measurement of angle B is. Well, it's approximate. And then once I know this is 33 and that's 90, right? I know these two add up to 90. So to find angle C, so the measure of angle A is 90 minus 33.69, which will be 56.31. And that's A. You've got all kinds of stuff to help you. Any questions? Chance to pipe up here. Okay? Less than 5 minutes to go. Way to stick with it. All right, now, same idea here, but I have an angle and a side. Just like I said, you can either do two sides, like this. That's the first example. And here's our second example. I'm given one side and one angle. Okay? You can find angle G because this is 90 and this is 25. So let's start with measure of angle G is 90 minus 25, which is 65. Gonna make sure I get it right. Yep. Okay, so this is 65 degrees right here. Now, in order to find G, I'm just going to use the numbers they gave me. In order to find little g, I'll use this side and the hypotenuse. So if I'm using 25, that's the adjacent side. So adjacent over hypotenuse is cosine. So I want the cosine of, no, sorry, don't do that. I want the cosine of 25 because I have the angle. And that's equal to G over 13. The cosine of this angle is G over 13. That's the adjacent over the hypotenuse. So then you multiply both sides to get, clear this, 13 times cosine 25 will give me 11.78, rounded. Now, if you use the other one, remember, this is for a TI, but remember if you do it this way, you'll have to put in the 25 first, then press cosine, and then times 13. So it's a little backwards, but you should both times get 11.78, depending on how you're doing that. Okay, so if this is 11.78, you could technically find h by doing the Pythagorean theorem, 13 squared equals this squared plus that squared, but it might just be easier to do the opposite side from 25, right? Here's the opposite side over the hypotenuse. So that's going to be sine of 25 equals h over 13. and you'll get the same type of thing. One calculation, 13 times sine 25 gives me this. Or the other way around, I do 25 sine first, and then I do times 13. Both ways I'm getting 5.49 as hundredths, because it said hundredth. Right? Hundredth. So 5.49. Questions? Yes or no? All right. Hopefully you feel strongly enough now that you can meet our objective, which is to find missing angle measures in right triangles. You've got, you know how to find sides, you know how to find angles, and hopefully you know how to use these trig ratios. There is one other type of problem, and that's a word problem. So you do need to know the word problems and draw the picture right. But the best thing is that you know it's just going to be a right triangle, okay? So your school is building a raked stage, and what that means is it looks like this. If any of you are in drama, here's the front of the stage over here, and it's just this, it's just a little bit of an angle, but this is a right, okay? The stage will be 30 feet long from front to back, so that means this is 30 feet. And it has a total rise of 2, so this is 2 feet. You want the rake, in other words, the angle of elevation, so that's right here, to be less than 5 degrees for safety purposes. Is your rake stage within your desired range? So if you want to find this angle, and you have this side and this side, this is the opposite side from the angle and the hypotenuse. So you're going to use the inverse sine, because you have the sides, you want the angle. That's when you use the inverse. 2 over 30, opposite over hypotenuse. Grab your calculator. So inverse sine, 2 divided by 30 equals 3.82 degrees. I'm just going to do it on this one to make sure. So I do 2 divided by 30 equals, I get that first, and then I press the shift sign, and I get the same thing. So the question is the rake stage within your desired range? Yes, it is less than 5 degrees. You would say something like that. Okay, so we're done with our notes for today. And this means, unless you have a question about your calculators, we're going to be, now it's time to practice.